Yeah. So we're on page 20, on number 20. They're asking for the second derivative, but didn't they already give you the derivative? So don't I only have to do the derivative one more time? Yeah, okay. Let's do it, y'all. Yes, listen to that. So we got d squared y over dx squared is, Soph said 3y squared. She's not forgetting that dy dx on this rainy day. Is that it? Yes. Because the derivative of 3 is 0. And then substitute then he goes, well, this is ugly. Could I put this in right there? He's saying, okay, I'm just going to go throw that in right there. So you're saying my second derivative is 3y squared times y cubed plus 3. Great, but look at these answers. I love it. Do they give us a point? They gave us a point 1, 2, and that might mess some people up. That is just the point 1, 2. F of 1 is 2. And you're like, well, oh, there's no x. And that's fine. That's fine. We're going to go plug in our 2. 2 goes in for y there. 2 goes in for y there. This is a non-calcy. 2 squared times 3. 2 cubed is 8 plus 3. What would 12 times 12 get me? 144. Would this be more or less than that? It's going to be less than it, right? So that might be a good technique to do because their answers are so far apart. Okay, so we're going to skip the middle one. We're going right down to this. I did put E in natural log on your test because I think that it's hard because that chain rule. The chain rule is going to be our worst enemy. We got to remember all of our layers. If I gave you y and they need this, how many derivatives am I doing? 2. Let's go do the first one. What would the derivative of e to the anything be? E to the anything. I love it. What would the derivative of 2 sine be? Awesome. So then when they want the second derivative, this is when you say, you nasty. This is gross. The second derivative, what rule will we have to do if that's the first derivative? Product, right? We got one thing times another. Whew. We got to do chain now in that product. Very good, Dicey. You can just use the first derivative. He's like, okay, so if I got to do f prime right here, haven't I already done that? Yeah. What's the derivative of e to the 2 sine of x? You're like, shoot, I already did that. It's this. So now my f prime is e to the 2 sine of x. That's the derivative of the outer times the inner. That right there is just f prime. What do we need to multiply that by? Thanks, my g. What do we then do? We got to move g prime. Derivative of 2 cosine. Negative 2 sine, or 2 times negative sine. I'm just going to throw that negative out front. So I'm going to change that plus to a minus 2 sines times my f. Thanks, Brady. Wow. Literally last period we were like, yeah, that doesn't look like an answer. Gross. Does this have anything similar to this? Do they both have something? They both have an e to the 2 sine of x. What also do they have?
They both have 2 cosine.
This guy doesn't have a 2 cosine. They both have a 2. Don't they both? So I'm going to say, all right, this guy's got an e2 cosine and a 2. This guy's got a 2 and an e bless you to the 2 cosine. All right, so we're saying that second derivative, can we factor that out? In fact, we'll factor out a 2e to the 2 sine. Oop, to the 2 sine? Yeah. What happens when I take out a 2e to the 2 sine? I got a 2 cosine squared? Is that right? Minus a sine of x. Yeah, that's gross though, isn't it? Ugh. Nah, AP won't have you do that. So we just took the derivative of the outer, we left the inner. Times the derivative of the inner, leave the inner. Lots of layers here. You guys, let's go put in a 1.5 for every x. Let's save ourselves a step. If I said 2 times 1.5, what could I put in there? 3. Times f prime of 2 times 1.5, 3 times a 2. Guys, the parentheses, we got to be really careful here. What would we need to find first? F of 3. Did they give us that?
Yeah. No.
Yes.
Daria said emphatically, no.
Oh, they did.
But Daria, they did. F of 3 is 2. So I'm going to say, all right.
I thought we have to like do it backwards.
Well, we're going to have to do something, though. So we need F of 3, we said, is 2. This is the part. Do we know what F prime of 3 is?
No. We know F prime of x.
Exactly. So if I know what F prime of x is, can I just say, all right, then F prime of 3 would be 3 cosine of e to the 3. Right? Guys, let's go grab that decimal on our calculator. Let's just go get it. What is 3 cosine e to the 3?
0.985.
Agreed, buddy. And which one do you want to say? Either one that you write down. Seamus just said 0.985 and 0.986. They're both great. I personally am a rounder. I'm going to say 0.986. And this is kind of what Lila and I were talking about. I'm a big parenthesis user. Lila was saying for the f prime of 3, Lila, if you remember this conversation, 0.986, you might have written it like this. And I always have mine in parentheses. Why do you think?
Because that could be mistaken.
You know what I'm saying? Like with us using the dots as multiplication and a dot as a decimal, it can just get confusing sometimes. So I'll typically do that just to alleviate having extra dots. Is it the same diff? Sure. And then I've got times 2. Here's what I need us to be careful on. G prime of 2, where are we going to get that info? Table. G prime of 2 is negative 3. G prime of 2 is negative 3 times 0.986 times 2. Could I end there? It's free response. If this was multiple choice, here's what I need you to be careful on. When you go type that into your calculator, do not type in 0.986. You got to go say negative 3 times that times 2. They're giving you a calculator for a reason, so they're expecting you to do that. So my answer is going to be, final answer, negative 5.914 or 5. I'm good with either one of those. But let me show you what I'd get if I didn't. Negative 3 times 0.986. Let's see if it changes it. Yeah, you see how that is not one of these two options. They would take off for that. But, so we just want to get used to, all right, if I've got that number, I'm going to write it to 3 decimals as I go. But whenever I need my calculator, I'm going to use the full digit. Sound good? Okay. This will be on your test, where I want the equation of a line. That's that point slope form, okay? What do we need for point slope form? Point and a slope. We've got the x coordinate. We need a slope. And look at what we're talking about. It says write the equation for this, which is the inverse of g. So if I were us, let's go take some of this info about g. Let's put it in a chart and make an inverse chart as well. We got this. Here's what I want you to do. Let's go make a g chart. Give me a point of g. I like to make it in a chart. What do we got?
3 negative 2.
3 negative 2. We're going backwards. Okay, give me another point.
2 0.
2 0. Another point.
0 1.
0 1.
Negative 1 4.
Negative 1 4. Do you agree we just kind of rewrote that table? Here's why I say that that's important for us, because it helps you guys visualize. If we got to think about the inverse, now tell me some of the inverse points.
Negative 2 3.
Agreed?
0 2.
0 2.
1 0.
Uh-huh.
4.
Good. Guys, they want the inverses function. So we need the inverses slope. If we're looking for an equation of a line, we need the inverses slope when x is negative 2. Ma'am. When x is negative 2 of my inverse, what point am I looking at?
3.
Negative 2, 3, right? We're looking at that point. What point does this go with of my function? Ooh, 3 negative 2 is the point that I care about. How would I find the inverse's slope here? It's going to be the reciprocal of this guy's slope. Do we know what g prime of what is?
Yes.
Yeah, do we know what g prime of 3 is? G prime of 3 is? Yes. Therefore, what would the inverse's slope be? Would be negative 1/4. What would you say at which x value? Agreed, right? And did they want that? Did they want the inverse function when x is negative 2?
Yes.
Yeah, they wanted that. So guys, I really think these tables are crucial for us to be able to visualize that. I think looking at that table is too overwhelming. So kind of extract what we need. You're like, okay, I'm just going to list some functions points. The inverse, all of them are flipped. If I need the slope here, it's going to be the reciprocal of the slope here. Yeah? Okay, but they want the equation of the tangent line. We have a slope. What would my point be when x is negative 2 of my inverse? We're still looking at that, right? So it'd be y minus equals my slope. Beautiful. Ugh. Get out of here. That will be on your test period. So now let's try page 23. I'm going to give you, I'm actually going to give you 10 minutes. I want you to try these on your own. 2. Perfect. Awesome. You took the derivative of the outer, you left the inner, times the derivative of the inner. So good. Now, where do they want that derivative? Perfect.
Can you also just leave it as x?
Yeah, totally.
0. Your f prime. Alright.
So now, could we figure out, do we know what f of 0 is?
3.
You agree f of 0 is 3. So we've got 2 times 3 times f prime of 0. Very good, Soph. She's saying, okay, they gave us f prime. So I got to go find f prime of 0. I'm going to kind of do that off the side. F prime of 0. Nice, girl. It's the cosine of 0 plus 0. Nope. It's 1. Because 0, the x coordinate at 0. Yeah. Yes.
No, it's just.
Yeah, times 4.
It's not to the negative 1/2.
Yeah,
Oh, yeah, because you subtract 1.
Now, Brady,
And then
could I have left this as my slope?
And now we.
Could I have put all of that right there? You could have, if you're worried about that, knowing what that is.
We might do that.
Healed. Sorry, Hitler. The one where?
Oh, never mind. I figured it out.
Oh, yeah. Unit circle.
It was hard to set up the chain